Everyone in AI right now is obsessed with one idea: make these models bigger and bigger. More parameters, more data, more compute. Scaling has worked remarkably well actually. 5 years ago, we have no idea that these language models could write a code completely end-to-end, pass medical exams or more complex exams, or have a conversation that feels genuinely human. And it got there mostly by getting bigger and bigger. But here's the thing that nobody in the industry wants to say out loud. Well, actually, some people are saying out loud. The people who build this technology are starting to admit it's not enough. One of the co-founders of OpenAI, and he was also one of the architects of modern AI, he said in late 2025 that we have left the age of scaling behind. His word, not mine. We are back in the age of wonder and discovery. Everyone is looking for the next big thing. And a survey of AI researchers published in 2025 found that 76% of them believe simply scaling up current approaches to reach human-level AI is unlikely to work. 76%. So what's actually going on and why does it matter to you? When I was doing my PhD, we worked something called scaling laws. But here's what every physicist knows. Scaling laws in physics always break. Always. There's always a point where the old relationship stops holding and something fundamentally new has to happen. The history of science is basically a history of people discovering where this curve ends. Newton's law worked brilliantly until Einstein showed us they didn't work at edges. So let's talk about why scaling hits a wall. There are 3 problems I want to walk you through, and none of them get fixed by making the model bigger. The first one, I call it the fixed compute problem. Every single word a language model generates gets exactly the same amount of computation. So suppose whether you ask it to compute 2 plus 2 or solve a complex mathematical proof, same number of processing steps are used. Same amount of thought. Think about what that means. A harder problem doesn't get more thought. It gets the same budget as an easy one. Now, the industry has found workarounds. If you ask a model to think step by step, it actually uses more computation by spreading reasoning across words. But here's what the research shows. Even inference time scaling, as they call it, hits diminishing returns. You keep spending more compute, costs go up, and the accuracy gains slow down. The second problem is memory, or rather the complete absence of it. Every time you call an AI model, it starts from zero. So if you take a simple task, for example, if you ask these models to write you an email or summarize this document, this doesn't really matter. But for anything complex, anything that requires continuity, anything that needs to understand history and context, and decisions made months ago, this is a fundamental blocker. The common response to this is just give it a bigger context. But research consistently shows that model struggles to actually use information from the middle of long context. More data in the window doesn't equal better use of that data. The third problem is these models don't know what they don't know. For example, when a language model is uncertain, it doesn't flag that uncertainty. It just generates the most statistically plausible continuation of your prompt. Confidently, fluently, sometimes completely dangerously wrong. This is what people call hallucination. And the uncomfortable truth is, it's not just a bug that gets fixed with more training data. Bigger models don't hallucinate less. They hallucinate more fluently. The errors get harder to detect. I'm not predicting some kind of AI winter. The next few years will still bring quite remarkable things. What I'm saying is that most important work in AI right now is not happening in the scaling labs. It's happening in 4 places. New architectures that give models more computation for harder problems, not the same budget for everything. Memory systems that actually persist across time. Interpretability research genuinely understanding what's happening inside these models instead of treating them as black boxes as we just make them bigger and bigger, and smarter agent frameworks that compensate for architectural limits through better system design. These are harder problems than scaling. They require the kind of fundamental rethinking that happens when a field hits the edge of what its current tools can do. If you want to go deeper on any of this, let me know in the comments. I'm building a whole series on exactly this. Please subscribe to my channel and I will see you in the next video.